Hey, eighth grade. So today we're going to talk about heat flow in the atmosphere. And one of the main things we want to talk about is this thing called convection currents. And we've been talking about convection currents for quite a while now. But I'm going to show you about this heat flow in the atmosphere. And we're going to start with talking about heat transfer during nighttime. So during the nighttime, as the air gets colder, it becomes denser and it starts to descend. As it then warms up by the process of heat transfer closer to the earth, you then have this air warming up by conduction, convection, and radiation. It gets less dense because now it's started to warm up. So those particles are moving much, much faster. And the air then proceeds to rise. The air starts to cool again. And as it cools, some of the heat escapes into deep space. When you have this happening, it gets colder and colder because the heat is escaping. And then it descends once again to warm up because this colder air is denser and the warmer or hot air is less dense, so it rises. So just like how we talked about the oceanic and the continental crust colliding, the denser one, or the oceanic crust, is more dense, which is why it slides underneath that continental crust. So just like that, when the air is colder, it's more dense, so it goes underneath the warm air. So you'll have this cycle, and it's called a convection current. Now, during the daytime, we get the same kind of thing going on, where you have this colder air up at the top, and we have this warmer air at the bottom. And because this warmer air is at the bottom, you have the sun putting in this heat energy. So this heat is being pushed into the system by the sun, warming up the air as it's trapped in because of greenhouse gases like CO2. And as it warms up, the particles start to move faster, it becomes less dense, and it goes up into the air and rises. Once that air starts to cool and some of the heat escapes, you start to have this colder and denser air, and it starts to fall again. And once again, we have this convection current. So there's a couple different types of energy transfer that we're going to talk about. And we like to call this radiation. And there's 3 types of this radiation from the sun. Infrared is the invisible radiation that we detect as heat. So if you think about an infrared cameras show the heat from your body or temperature differences in heat. And this is how they're able to search for either people or things like that nature. Because of the heat that you're letting off, it detects that heat. And then it will usually show that image as red, as a warmer area. Visible light is the radiation we actually see. And UV light is the invisible high energy radiation that can be really damaging to your skin. Now, our ozone layer usually protects us against this UV light, but when you have things like ozone depletion due to pollution, that's when you start to not have this protection anymore. Sunblock is also to block UV radiation. So the clouds in the air molecules reflect or absorb about half of the sunlight, and the other 50% strikes the surface of the earth. The sun produces most of the energy that actually drives the Earth's weather and climate. So all of the energy that drives this entire climate system on Earth comes from mostly the sun. And the transfer of heat from the surface of the Earth back to the air energizes the atmosphere, and this then produces our weather because it's putting all of this energy when this heat is transferred from the surface back into the air. So don't forget, when we talked about this idea of the greenhouse effect, is where gases in the atmosphere traps that radiation and it's being reflected back from the surface. This actually conserves heat. So you'll notice in this picture right here where we have this natural greenhouse effect, you have the solar radiation coming down, and then you have these greenhouse gases that trap this into the atmosphere. And this can power your convection currents because you have energy coming in and it heats up, and those then hotter areas of air rise to the surface because they are less dense, while the cooler air sinks to the bottom because they are more dense. Now the problem is when we have this human enhanced greenhouse effect. You have too much energy coming in, too much heat, and it starts to cause things like bigger storm systems coming through because there's so much energy in the atmosphere. It can also lead to increased temperatures, which then affect the amount of ice on Earth and therefore the sea level. You have 2 different worksheets to do today. One is a crossword puzzle that I want you to try to do on your own. There's a word bank underneath your notes for it. The second one is a fill-in-the-blank worksheet. I want you to answer that one using the internet to help you and then move on to your exit ticket.